Hello everyone, we're going to start our next section. I hope your Chinese New Year holiday was good and filled with lots of sleeping. Um, in this section, we're going to be given lots of different questions where we're given different polygons, so that's going to be like a triangle, a trapezoid, square, rectangle, whatever. And we're asked to classify these more specifically and ask if this triangle is equilateral, ask if this quadrilateral is a square, kind of questions like that. And in order to do that, we're going to have to use a couple of different formulas and when you're going to have to use it. So one of the formulas is the distance formula. These formulas, remember, I'm not going to give you on a test, so you have to remember it. So it's the x-coordinate minus the other x-coordinates, and then that's squared. And the y-coordinates minus each other, and then they square. And then you add those two squares together and take the square root. So you're going to use this for when you want to see when the sides are congruent or when the diagonals are going to be congruent. The next point is the midpoint formula, and that's the x-coordinates added together and then divided by 2, the y-coordinates added together and then divided by 2. You're going to want to know when you want to find the midpoints of a side or if the diagonals bisect each other. And then the last one is the slope formula. That's the y values subtracted divided by the x values subtracted. And then you're going to need to see if the opposite sides are parallel, or if diagonals are going to be perpendicular to each other, or if the sides are going to be perpendicular to each other. So these are the three formulas that we're going to be using. I will not give you these on a test. I expect you to know them. Okay, so next we're going to go into a couple of different questions on when to use these and how to use these. Okay, so for this one, I don't have a picture for it, but we don't need a picture for this one. We're given a triangle with these three coordinates, A, 0, 1, B, 4, 4, and C at 7, 0. And we're asked, is this triangle going to be scalene, isosceles, or equilateral? So when we're going to be doing this, we need to know only about the sides, so we're going to be using the distance formula for all these. For AB, we have 4 minus 0 and 4 minus 1. 4 minus 0 is 4, squared is 16. 4 minus 1 is 3, squared is 9. Add them, take the square root, 5. B and C, 7 minus 4 squared, 0 minus 4 squared, 9 plus 16 again, and then 5. So far we have two lengths that are the same, and so we can cross out the fact that it can be scaling, because that's no sides the same. And we check the last one. 0 minus 7 squared plus 1 minus 0 squared, which would be 49 plus 1, which is radical 50, which all reduces to 5 radical 2. So we have two sides of the same, one that is not the same. So we have two sides that are the same, that would be 5, so that means that this triangle is going to be an isosceles triangle. Alright, now I'm going to give you a question basically doing the same thing with a triangle. Alright, next one we're going to be doing is working with a parallelogram. So again, I don't have a picture, again, is ABCD a rhombus? So we have these points A, -2, 0, B, 0, 4, C, 4, 5, and D is 2, 1. So if we want something to be a rhombus, we can check check the slopes of their diagonals. If we check the slopes of their diagonals and their diagonals are perpendicular, then it's going to be a rhombus. So the slope of A and C would be 5 minus 0 over 4 minus -2, which is 5 over 6. Slope of BD is 2 minus 0 over 1 minus 4, sorry, 1 minus 4 over 2 minus 0, which is -3 over 2. Remember, you have to do y values, so I messed up that. So it's 1 minus 4 over 2 minus 0. So check if these are perpendicular, you multiply them, and they should be equal to -1. When we multiply them together, it's not equal to -1, it's equal to a -15/12. So since these are not equal to -1, the diagonals are not perpendicular, and the shape is not going to be a rhombus. I'm going to give you another one where I give you the coordinates, and I'm asking you, is this going to be a rectangle or a square? Alright, we're going to go into one last problem dealing with given a shape and figuring out if another shape inside of it could be something else. Okay, so this time I decided to have the coordinate plane with us. So we have this kite with these coordinates. This is K, I, T, and E over here. What is the most precise classification of the quadrilateral formed by connecting the midpoints of these different sides of the kite? So in order to do this, first we need to find the midpoint of each one of these sides, draw lines connecting the midpoint, and then figure out what kind of quadrilateral that is. So it's a multiple step problem. So first we find the midpoints of these lines. So the midpoint of Ki, this one would be Ki, we do -4 minus 0 divided by 2, 0 plus 4 divided by 2, so we have -2, 2, so it would be right about there. Midpoint of this one, 0 of I and T, would be 0, 8 over 2 and 4, 0 divided by 2. C would be 8 plus 0 and over 2 and 0 minus 4 divided by 2, so it's 4, -2. This one would be right about here. Sorry, midpoint of B would be right about here. Midpoint C here, and midpoint D at -2, 2 right here. We'll go over this in class again if you guys have any questions about it. And then what you're asked to do next is to kind of draw on here because it's easier to see it if we can draw. I'm not going to be able to draw it just because if I draw it I'll lose this piece. So just imagine drawing on here. So we have shapes that go in like right here. Then we have to classify this. So AB, we're finding the distance of this. So it's 4 minus a -2, which is 6, and -2 minus 4, which is also 6. So this is AB up here and CD down here. BC would be -2 minus 2, which is 4, and 2 minus -2, which is also 4. We're not using the regular distance formula in this question, we're using the distance formula as it would be like on a number line. Since we are in the coordinate plane and we do have straight lines, we can think of it as things on the number line since we can just count the boxes like that. So we have opposite sides are congruent, so ABCD is a parallelogram. Since AB, this one up here and down here, are both horizontal, and these two BC and DA are both also vertical, they form right angles. So we have lines that are horizontal and vertical. Horizontal and vertical lines are going to be right angles. So we have lines that are opposite, are congruent, and make right angles. So we're going to have a rectangle here. And we have one more question basically doing the same thing, but just instead of starting with a kite, we're starting with a different shape. Okay, so that's going to be it for today's lesson. And in class, we're just going to do some individual work and group work, mostly probably from the textbook.